How's it going, everybody? And welcome back to our Cisco Enterprise series. In this video, we're going to go ahead and start digging into the implementation of IS to IS on all of the platforms we're going to be working with. Like I said, this will be a very straightforward deployment. I'm going to walk you through just what's required first to get it working, and then we're going to do some review, look at how the databases are built, look at how the routing tables are built, stuff like that. And then once we have all that done, we'll go through and we'll stand up a level 2 deployment only. We're just going to change the IS type across the board and go from there. So we're not going to be doing any inter-area routing or anything fancy like that. Like I said, IS to IS is not a topic on the blueprint at any point in time unless you go in the service provider track. So what I'm showing you here is just so you're generally familiar with how the protocol works and a basic deployment of it, so you'll be able to recognize it when you see it. With that being said, let's go ahead and dive into the interesting parts of the conversation. Configuring NSAP. So IS to IS packet routing. IS checks the packet's destination. If the different area, route based off the same area address. If in the same area, route based off the system ID. For a level 1 router, inter-area packets sent to the closest level 1, level 2 routers. Inter-area packets are routed to, based on the level 1 database. For the level 1, level 2 router, inter-area packets are based on the level 2 database. Inter-area packets are based on a level 1 database. When it comes to forming IS to IS adjacencies, ensure transport first. So CONS resolution on the multi-point NBMA, IP and IP tunnels. Level of adjacency must match. Area must match if level 1 adjacency. Network type, broadcast, or point-to-point. We're going to go through and once we get a couple of routers built, we're going to go through and do point-to-point everywhere, just so that it makes it easier to configure. For IS-IS configuration on iOS, you're going to turn router IS-IS on. I'm going to use, based off the topology, we're going to use the term MPLS. Then we're going to create the network entity title. The net is going to be that 49 and then your 6-byte address, followed by your 00 for your end cell. Once you've done that, then we're also going to turn logging on, because logging by default is not enabled. We're going to go underneath the interface, and we're going to type in IP router IS to IS, and then the name. And then we're going to set the IP, or the IS to IS network type is going to be point-to-point. iOS XR is a very similar configuration stanza. We're going to configure the process, define the net, and then go underneath. We have to create router IS to IS. We're going to enable the address family IPv4 first, and then we'll go underneath the individual interfaces and configure that with IS to IS. Alright, so I'm going to go ahead and minimize the screen. I'm going to go ahead and pull over Secure CRT, and we're going to go ahead and get started with this whole shebang. I'm going to minimize this because we don't need that out. I'm going to start on router 30, and we'll go through the configuration process. Go to global config, and I'm going to go to router IS to IS MPLS, type in log adjacency changes. I'm going to set the net to be 49.000 dot 0030.0030.00. That's what I'm going to do. So I'm what would be the same area. Okay. And then now that I've got that done, I'm going to go over to interface. I'm going to do gig 00 and gig 01. Actually, let's do gig 00 real quick, just for kicks and giggles. IP router IS to IS MPLS. That's all I have to do. I'll do the same thing on 31. So we go to global config. We'll type in router IS to IS MPLS. Put in your log adjacency changes. The net is going to be 49 dot. Just like that. We're going to go underneath interface gig 0/0. Type in IP router IS to IS MPLS. Okay, so now I should form an adjacency here momentarily with that router, and I do. Now if I type in do show IS to IS neighbors, I can see that I form an adjacency Everything seems to look pretty good. I form a level 1 and a level 2 adjacency. We go over to 30 and look at the same thing. So do show IS to IS neighbors. Everything looks pretty good. And if we look at how this is looking, if you notice right here for level 1 and level 2 that we have the .01 here. This is going to be our designated intermediate system. Okay, so that's essentially what that's going to look like. Now if I haven't advertised anything into the routing yet, because all I've done is enable IS to IS between these two interfaces. Very, very simple deployment. If I go to router 30, router 31, type in loopback 0 and do this, and then I jump over here to 30 and I go to interface loopback 0 and do the same thing, and I type in do show ISIS database, we're going to see the loopback come across. We'll see it might take it a couple of seconds for it to come across, but do show IP route, we're going to have the loopback right here come across, level 1 adjacency. Okay. Now beyond that, that's pretty much it. There's really nothing more to it than that. The way that this 20 is calculated is on router 30. In order to get to router 31's loopback address, I have to go a hop count of 10, a metric of 10 to get over to 31, and then for 31 to route to its loopback is another 10, which gives you a total of 20. That's how that's calculated. So with that being said, let's go ahead and on here, I'm going to go back to interface gig 0/0 and type in IS to IS, and I'm going to say the network here is going to be point to point. I'm going to do the same thing on the other side for gig 0/0. Paste that in. So now it's a new adjacency, so do show ISIS neighbors. And that's looking pretty good. We'll do the same thing over here. Do show ISIS neighbor. That looks good. Changes the way that the output looks a little bit. We're a level 1, level 2 adjacency. And that's looking pretty good. Okay, so do show IP route. Same look and feel, right? Nothing really changes from that perspective. Do show IS to IS database, and everything looks good, right? Eventually this guy right here will time out. That's what, if you see parentheses, because we looked at this before, there is no parentheses around anything the whole time. Eventually this will age out. I don't know exactly now how long it's going to take, but eventually this will age out because you have this is basically telling me that this is the DIS and this LSP is no longer valid. So with that being said, I'm going to go ahead and going to include that command everywhere else. So on router 30, I'm going to do interface range gig 0/1 through 4. I'm going to type in IP router IS to IS MPLS and type in IS to IS network type is point to point. Okay, so I'm going to do the same thing on 31. Interface range gig 0/1 through 4. IP router IS to IS MPLS, and then IS to IS network type is point to point. Then if I jump over to 32 and I go over here, router IS to IS MPLS, log adjacency changes, the net here is going to be 49. Just like that, and then I type in interface range gig 0/0 through 1, IP router IS to IS MPLS, and then IS to IS network type point to point, and then interface loopback 0, enable that. Then I go over to 31 and I see the new adjacency comes up, do show IS to IS neighbors. We can see that. Now if I go back to the database, do show ISIS data, again we're going to see this guy going away, right? So that eventually will time out and we'll be in good shape there. So we are good to go there. Let me take a look at it from 30's perspective. So we're looking pretty good. So I don't know what this one here is. I don't know why that's there, to be honest with you. That doesn't make any sense. But this one eventually is going to get, I think that might have been because when the adjacency formed initially, the network type was still broadcast, and when the initial communication went back and forth, it detected broadcast, and so the DIS selection process went through. Maybe that's what that is. So let me try doing this a little bit differently on some of the other routers and do the network type first and then enable IS to IS on it to send the discovery process. So what I'm going to go do is I'm going to jump over here to 64. We'll do 64 real quick. We'll type in router ISIS MPLS. We'll set the network entity title to be 49.64.00. We'll log adjacency changes and interface gig 1, IS to IS network is going to be point to point, and then IP router IS to IS MPLS. Interface loopback 0. Do something like that. Now let's go back over to 30 and see if that makes a difference. Let's do the neighbors. See our neighbor statement real quick. So 64. Okay, the circuit ID showed up 00. So if I look at the database, 64. I think that might have been the kicker. So for this one particular instance on level 1, it detected a DIS selection process. So eventually this will go away. So I think that was the caveat. So we're in good shape here. So as long as we go point to point, we'll be squared away. Now, one thing I'll be honest with you with is if we were to go forward with MPLS traffic engineering, with IS to IS, doing the point-to-point network type would be required if we're going to do anything like fast reroute or anything like that, which is an MPLS capability, which will allow us to build backup MPLS tunnels between some of our routers. So if, like, for example, if our main label switch path was 64 to 30 to 31 to 65, for example, it was to take this path right here. Well, if something happened with this link right here between 30 and 31, and we had an alternative path through 47, you could build a path from 30 to 47, from 30 to 31 via 47, and it would leverage the make before break option. So you would make the tunnel before you'd break the connection. So you would be able to route around this link failure, which is what they commonly refer to as link protection. So that is going to be a caveat down the road when we get into more advanced topics, but that's more of a service provider specific technology and use case. But just in case, the topic of conversation does come up, at least you'd be generally familiar with it. All right, so now that that's been covered, let's go over to 64. I'm going to do show run section IS to IS. And what I'm going to do is I'm going to pull out Notepad, and I'm going to give you guys the CCIE pro tip. So here's what we're going to go do. We're going to go grab this config right here. We're going to do this. And then I'm going to do a do show run interface gig 1 for this config right here. And we're going to put that right there. I'm going to hit the up arrow a couple times. And I'm going to type in interface gig 1 and then do show run interface loopback 0. We're going to grab this config right here. And we're just going to schwack the IP address, pull that out. So this is the syntax we need in order to move forward. So what I'm going to do here is I'm going to do 65 and do that. Copy this over to 65 to try to optimize our configuration time. So paste that in, and then for 66 we'll do the same thing. and copy pasta, just like that. Okay, so now that's done, we're gonna do show IS neighbors. That's looking good. So let's look at 31. 31 should have a new adjacency. Do show IS neighbor. That's looking good. Perfect. Do show IS database. 66 is looking squared away. So these other timers here, this LSP is going to go away. This LSP is going to go away. I'm sorry, this one right here. Perfect. So now I get to go and configure what I need to for XR47 and XR46. So what I'm going to do is for 46, I'm going to go ahead and make an example out of this guy. And we're going to go ahead and let's do rid of this because we're doing non-area example. So I'm going to come down here to these guys, and it should be network point to point. I'll verify that config though before I apply it. So let's jump over to here to 47. Login is Rob and Cisco. Let's go to global config, router, ISIS, MPLS, and then we're gonna copy this piece in right here. Like that, and then we're going to go underneath the interface, and the network command should be it won't be for the loopback. Interface gig, and the network. Okay, so it's going to be an address family specific command, point to point, so we can schwack the network statement. I wasn't sure exactly on that piece, but it took me all of 5 seconds to figure that out. Just like that. And we're going to go ahead and take that information right here. We're going to paste it in. We're going to do a quick show config. Okay, perfect. So I'm going to go ahead and let me come back to here and type in log adjacency changes. Do a show config again. I'm going to literally take all the syntax out, put it right here, and I'm going to go ahead and commit. And then I'll do 46, the same thing. But in this time here, I'm only going to need gig 0, 0. Just like that. We're going to go over to 46. Go to global config, and then paste it in. And then we should form an adjacency with 30 here momentarily. Do show IP interface brief. So did I 46 do show run interface gig 0/4. Okay. Let's see what the deal is here. Do show run router ISIS. Did I not enable ISIS? I did. Oh, did I not commit it? Huh. Jeez Louise. The one thing that I forgot to do, commit the config. No wonder it's not working. Good grief. So do show IP route. So, alright. Now we have a fully deployed environment. We have a lot of level 1 peerings because we're all in the same area. Totally expect to see that. So, and we can see that it's IS to IS level 1. Level 1 IS. Right? So, if we see IS, that means a little I, and then level 1 means level 1 IS to IS, level 1. Level 2 would be IS to IS level 2. So now the question is, how do we convert from level 1 to level 2? And the answer to that question is very simple. We simply change the IS type to level 2. So we will actually get rid of all of our level 1 adjacencies if we do that. So I'm going to start off here on 30, and we'll do a do show IP route. We're going to see a bunch of level 1 stuff first and foremost. So I'll type in here router IS-IS MPLS. I'll type in here IS-type is going to be level 2 only. Now when I do that, that's going to clear the adjacencies, and it'll bring the adjacencies back up. Do show IS-IS to neighbor, right? Now the problem with this is though, is we're only going to form level 2 adjacencies. So the other routers eventually will come back online. This usually takes a moment or two for it to do its thing. So on 30, we took it on a major router. So 31, so the downtime expired. We form a new adjacency for 46 and 47, 31, 64. Okay. So we have everything back up. 31, 32. Looking good. Perfect. Do show IP route. Now the way it's going to look from this guy's perspective is it's going to be level 2 only. Now if I look at 31 though, do show IP route, he is a level 1, level 2. So he's going to see stuff to get to level 30, it's going to be level 2. In order to get to 46, it's going to be level 2. In order to get to 64, it's going to be level 2. In order to get to 46, it's going to be level 2. But anything else that's level 1, you'll go via level 1. See how that works? So you can do a mixed bag if you'd like. I don't recommend it, but it's possible. So I'm going to go ahead and just flip them all over to level 2, and we'll get that process knocked out. So on level 2 here, we're going to simply just grab this command right here. On 31, router IS-IS MPLS. We'll simply grab that syntax. And go to 32. Copy pasta. Same thing with 64, 65, and 66. There we go. And then 64 and 46 and 47. We'll come over here and type in IS-type as level 2 only. And do the same thing at 47. All right. I'm going to give this a moment to do its thing. All right. So it looks like everything has synchronized. So we're going to do a do show IP route. And we should have level 2 everywhere, which we do. All right. It's been up for a couple of minutes now. Everything is squared away, so we're in good shape there. So that is pretty much what I wanted to show you guys in this video. Very basic implementation, nothing complicated about it. So what we're going to do from here on out is this. So just so everybody understands where we're going to go. Now the MPLS section has already technically started. I've gone over some of the high-level details of how it works and stuff like that. My goal is to show you the layer cake that MPLS, and then so you got MPLS, right? You got IGP, BGP, and all that good stuff that goes along with it. I'm sorry, IGP, LDP, BGP. And then once that's in place, then you have to do the layer 3 VPNPs, which is VRFs and PE to CE routing. So once you understand all those individual layers of the cake and you build them, build one layer at a time, it makes it that much easier to understand. And then you can go forward down the road with more complicated implementations. So that is where we are at right now. So actually we haven't gotten to the point where layer 3 VPNs are in place. So we are getting the IGP squared away so that I can circle back and go, okay, now that IS to IS is in place, we can go forward and get LDP working. So this video will be kind of dual purpose. I'm going to have it in two different places. We're going to have it in the MPLS section to stand up IGP, and then we're going to have it also in the IS to IS section And if you see the same video twice, that's because it is. Actually, I'll make a note of this, that this video is a reproduction, so we'll be using it twice to get the job done. So with that being said, if you guys have any questions, comments, concerns, feedback, drop that in the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you fine people in the next video.